Okay, so we're going to start with spirals. And spirals, and we talked about at the very beginning of the chapter in section 24:17. But spirals are used to provide a gradual transition in a horizontal to a horizontal curve. So even though I said that it's used mainly on highways, that's not the only way you use it, in high speeds. The definition or the description is it's used to provide a gradual transition in horizontal curves. Remember that. You will see it again. The most common use is to connect straight segments of the alignment with a curve. So it goes from the tangent to a spiral, and then a spiral to a curve, and comes right back out. So if you lead in with a spiral, you exit with a spiral. The reason for that is it lessens the sudden change in direction that would otherwise occur if you were coming around a sharp curve. Since spirals introduce the curvature gradually, they afford the logical location for introducing superelevation, and I'll explain what superelevation is. We usually do that more in like topo and site, to the centrifugal force experienced by a vehicle. So if you were looking at a racetrack and they're going around in circles, that racetrack's on a banking. It's on a certain angle of degrees. That's with the centrifugal force. So usually if you go into highways and you go into curves, the road will actually, you start lifting up to let you go around there without having to put on the brakes. When you were looking at major highways, it'll super elevate up. So now we want to talk about some of the basic numbers that you're going to need and the equations you're going to need. So right now you'll have a PI. So from the PI, you'll need to figure out H. And H gives us the station for the PT, the TS. So here's your back tangent. TS means tangent to spiral. And then you'll have a little spiral coming in. This will be your SC. So this is spiral to curve. Now this is your typical curve like we normally would figure typical curves. And then you go back into from a curve to a spiral, and then the spiral to the tangent. So you're coming back out. So you're always going to lead in with the spiral and exit with the spiral. The PI's here. We need to solve for H. And so typically we've got an equation for X, an equation for Y. We'll be able to solve for H. We'll be able to solve for what that distance is to subtract to get our TS station. Alright, so for this theta S is right here. And we're going to need that a little later on. So I highlighted that one in green. So SC, since the change is uniform, so our spiral, the change is uniform, the average degree over the spiral length is d over 2. Thus the difference from the definition of degree of curve, spiral angle is theta S. So it's theta S equals the LS d over 2. And d would be your degree of curve. So typically that's given. Now I need to make sure in this equation that L is in stations. So if it was a 300-foot spiral, that number should be 3 stations. Theta S and D are degrees. So like I said, we'll come back to that. Now I'm going to go ahead and skip down because that's not, and here's theta S again for you, so it kind of lets you know what's going on. Alright, so if we're trying to lay out the curve, there's a couple of things we're going to need. We're going to need equation 2427, which would be the length, the length to the point, and I'll show you how to do it later on. So it would be your LP over the length of your spiral squared. And then if you solve for theta S, that would be a degrees divided by 3. So we'll come back and use that one in just a minute. Okay, the next thing I highlighted is because we need x and y for h. So here is our h formula, and that's all the work that we're going to do is just going to come back to work with this h. So I've highlighted x and y. Now you've got a bunch of numbers in here. These are constants. So LS, and LS is in stations again. So we're going to work with stations. Remember stations, you move your plus. So let's say it was 300, it would be 3 stations. If it's 200, it would be 2 stations. So we're going to use that number of stations. So all you have to do is wherever the plus is, drop the plus, and you put your decimal point. That's easy enough. Or you can divide it by 100. Alright, so x equals the length of your spiral, and that's usually going to be given. And then it's 100 minus, and it's got this crazy number, 0.0030462 theta s squared. And the answer will be in feet. And then we'd solve for y. And then we'd come down and we're going to put our y. This equation 2413 is what they call the word throw. T-H-R-O-W. Throw. And we need throw to be able to solve for h. Now they've taken all of this, the calculations and the trigs and any other thing, and reduced them for us. So basically we're just going to do a plug and chug, and I'll show you how to do that. So we're going to use a couple of these equations, and I will show you how to get started. So remember, these are constants. Remember when you're working to pay attention if LS is in stations, and typically they are. When I put it here, it doesn't matter if it's stations or degrees. I'm going to put it in the regular length, not stations, and we'll see how it comes out. And so we're going to have a little solving to do. Alright, so it gives us homework example 24.6. So a spiral's 300 feet, so that's your LS, so that's given. It's used to transition into a 3 degrees circular curve, and its arc definition. So this 3 degrees is your D. And then you've got I for the PI, and it gives you I, which is 60 degrees, and PI, which is 20. So I'm going to come over here. Alright, so most everything is given. So we want to solve, because this one is arc definition, we want to solve for R, because you need R. So I'm going to use equation 24.3, which is R is equal 5729.58 divided by D, which is 3 degrees. And it just doesn't matter if you put seconds. And it'll give you R. So if you solve for that, you should get 1,909.86 feet. So we just solved for R. Now we want to solve for the theta S. So I'm going to write theta S. And I'm going to go over here and show you. We're going to use the equation 2425. Theta S equals the length of your spiral, D over 2. Now this time, remember, it says LS, the length of the spiral, needs to be in station. So if I say theta S is 300 feet, so that would be 3 stations. So if something's 300 feet, to put it in stations, you would divide by 100, because there's one station is 100 feet. So that's how you would calculate a station. So just pay attention on what they asked for. And then that is going to be times d, which is 3 degrees, divided by 2. So it just worked out that this was, and when it gives you this, it's going to give it to you. So theta s is an angle. So when it gives it to you, you're going to be given a degree, minute, and second. So once we solved for that, it gave us, oh, sorry. This thing's going crazy on me. I'm not even touching the tablet, it's going crazy. It should give you 4.5 degrees, and then if you put that in degrees, minutes, seconds, it would be 4 degrees 30 seconds. So that would be your theta s. Alright, good so far? Alright, so we are going to solve next for x. So I'm going to go ahead and get the formula for x and write that in real quick. So we're going to be using equation 2428, which will be x equals ls. Try to write small so I can get it all in. The 100 and this 0030462 is a constant, and then theta s squared, and this answer is going to be in feet. Okay, so x again is going to be in stations, so that would be x, so ls is 3. All these calculations are just to get us h, 4.5 degrees squared. So it looks like that. So that's just a kind of a plug and chug, not anything really. So your x should be fairly big, depending on your curve. So ours is 299.81 feet. And I'll show you where that x is. So I've got x highlighted in pink. So we're solving for x, and we're going to solve for y to be able to plug it into our throw calculation, which is equation 2431, and then to finally solve for h, which will give us the beginning of our spiral. The spiral is really easy to do. Okay, so now we want to solve for y. So I'm going to go up and get my equation for y. And now, so y equals, and I'm going to say equation 2429. Y equals ls. And again, the numbers that are in here are constants, 0.58178. So that is a constant. I'm going to have to write this below here. I'm not going to get all that big number in here. 0. So I'm writing all this out. This is probably one of the hardest problems to work. And this is theta s cubed. So it looks like that. So all that, I'm going to go ahead and plug the numbers in. So y equals, LS in stations is 3. I'm just going to put out. And then we have theta. And this is 4.5 degrees. I'm going to put me some brackets. Minus. I'm going to put the second right below it, since and these numbers that are in here are constants. Aren't you glad we didn't have to drive all that ourselves? And then theta S. Oh, I'm going to have to delete it. Look at that. It's an extra 0 right here. And theta cubed. Okay. Alright, so once we solve for that, our y we should have been given, and I'm working right here, example 24:6. So y for the problem would be 7.86 feet. So that would be y. So you can see it's small. It's kind of like we're setting up a right triangle. But we're solving for x and y so that we can solve for the throw, which is this little distance here, and we need that to solve for our throw up here, and then to eventually get the h. Alright, so I did x and y, and we need to solve for the throw. And there's the throw calculations. I'm going to come on down. So we're going to solve for throw. Throw equals the y. I'm going to write the formula first. Y minus r. 1 minus cosine theta s. So throw equals 7.86 minus our r. And the r we solved was that 1909.86. And then 1 minus, and then our cosine theta, our spiral, which is 4 degrees 30 seconds. Looks like that. Alright. So if you, yep, got it all. And when you solve for that, you should get 1.97 feet. It's good to work along with me. That way you can see by chance if your calculator you put something in wrong. That kind of helps you if you work along to make sure you're getting the right answer. Alright, last thing we're going to solve for is the h. And h is what we need to get our, so h equals x minus r times sine theta s plus, I'm going to put this second part underneath here. R plus the throw tangent I over 2. Okay. So we're solving for H. So H equals, our X was 299.81 minus the radius, which we solved to begin with, and then I'm kind of breaking it down. This is supposed to be sine 4 degrees 30 seconds. Then we're going to say plus R plus throw, so that would be your radius, 1909.86, plus 1.97, which is throw, and then we're going to do tangent, and this is I. So in the problem, I was 60 degrees, so they just went and cut down to, and did, I'm going to go ahead and leave it in 60 divided by 2. That's given. So if you solve for your H using the numbers, you should get 1,253.75 feet. Okay, so what that does is that's going to give us the H. That gives us H. So if you got the PI, all you have to do is subtract H, and that'll give you where the spiral begins. So just like here, I'm going to scroll down. If our PI is PI is 20. 20 plus 0, 0. I'm going to keep all the zeros. Like I said, I like to come over here and just take the plus out and say 20 minus 1253.75. Or the way they did it is they said minus, they put the 1200 in stations. So remember, when you do stations in feet, it's always going to be from your decimal point 1, 2 over, and that'll be where the plus is. If it's metric, it's 3 over, but for English units, it's just going to be 2 over. So if you solve for that, you're going to get, that's where the spiral begins, is TS. 7 plus 46.25. Looks like that. And then they gave you LS, which is length of the spiral. So LS was given, and that was 300 feet. So it'd be 3 plus 0, 0. So then where the spiral goes to the curve, that station would be 10 plus 46.25. So not bad, not really bad. It just breaking it down. But we did all those equations just to be able to solve for our curve. So we're ready. I'm ready to get you started. All right. So we want to set the curve up like a table 24/7. So there's our TS that we just solved for. And there's our SC. So this is a 300-foot spiral. And we want to set up a chart just like this. So this time our LS is the distance between the station you're at minus the TS. So it's not between each other, it's going to be the distance from the TS, because we're going to use that in the formula to get, we're going to come back up and work this formula right here. Alright, so we're going to go ahead and solve these. And we're going to be using this. Alright, so when you plug it in, like you'll put your numbers. So this one was 7 plus 46, 25. You want to stake, this they're having to stake every 50 feet, so that's half station. So you go up to the next even station. That'd be 750, 8, 859, 950, 10, and the last one's a spiral. Now, this distance for column 2 is the distance between what station you're at and the TS. So the difference between these two is 3.75, and then you can just add 50 every time. And then you'll have that little bit extra, and it should be whatever the length of your spiral is. Now, when we're plugging this in to get this deflection angle, we're going to go back and we're going to use this equation. Excuse me, right here. So 2427. So I'm going to go ahead and just 2427 is going to give us the deflection angle. So it's LP, which is the distance that we have in column 2, theta S cubed, or divided by 3, sorry. Alright, so that is equation 24/7. So let me go back over here and show you really quick. Alright, I'm going to go ahead and work a couple of them. So if I'm wanting to get the deflection angle here, the LP is your column 2, so that would be 3 plus 75. I'm going to leave this in feet, so that would be 300. 4 degrees, 30 minutes, divided by 3. So I'm going to scroll up and I'm going to solve for that real quick. I definitely got something different. Maybe they did put it into stations. Type real quick. These are typically small because remember you're transitioning. Got something a little different. I worked it out last night and had it. Let me look at it again. So, I got my distance, my feet, my theta S, and I want to get deflections. And they put it in decimal degrees. sure I got my... Oh, I see what I did wrong. That's really quick. Made a dumb mistake. I didn't square it. Right there's your squared. So I'm going to leave it just the way I have it. And let's try it again. So 3.75 divided by 300. And we're going to square it. And then I'm going to multiply it by 4 degrees, 30 minutes. And that's divided by 3. When I get that, I get a really small answer, and that's in decimal degrees. So I've got to change it back to degrees, minutes, and seconds. So I'm going to do second angle on my calculator and go down to 4, which is degrees, minutes, and seconds. So when I solve for that, I got 0 degrees, 0 minutes, and not even 1 second. And got 0.844 seconds. So basically nothing. So I'm going to do another one. So let's look at, I'm going to go ahead and each one is done separately, so it does not like it's building. So let's move up, and I want to do the 9. I'm going to do the one for 9. 9 plus 0 is 0. Alright, so my L, which is column 2, is 153.75 over the 300, which is the length of your spiral. Square it, and theta S is 4 degrees 30 minutes, and that's divided by 3. So I'll plug this in and we'll see what we get. Now make sure you square it, and then times, and I'm doing the degrees real quick. So when I solved for that, I got what they got a little. So when I solved for that, I got 0 degrees, 23 minutes, and they did decimals of a minute, and I got 38.344 seconds. So that's kind of what you would do, and that would give you each of these columns. So all you're going to do is sub out for this formula. You're just going to sub out what the LP is. LP divided by LS squared, theta S over 3. And then that'll give you your deflection angles. And then if you're staking it with the total station, you would do the total chords. But if we wanted to tape it and get the distance in between, you're just going to measure the distance between each station. So 7 plus 46, 25, 50 would be 375. Then all of these that are 50 feet apart would be 50, and then the last one would be the 46, 23. So that would be how to calculate a spiral. So I'm closing out.